Okay, chapter 10, mechanical wave. 10.1, properties of wave. So learning outcome today is 3 learning outcome. 10.1b, solve problem related to the equation of the progressive wave. Then the second one is use particle vibrational velocity and wave propagation velocity equation related to the equation given. Then 10.2b, use the standing wave equation. Okay, so first learning outcome. Solve problem related to equation of progressive wave. As you know that progressive wave is come from longitudinal and transverse wave. So they are represented by this equation. Y is equal to A sine omega t plus minus kx, where y is the distance from the particle from equilibrium. So means that this line is component y and component x. So y is represent the y component, means that from the equilibrium position of to any position of vertical. So that's we call as y. And then A is amplitude, means that the maximum position of the y component. Okay, sine is the function of the graph. Omega is the angular frequency or angular velocity. So t is time, plus minus is the wave propagation, where the positive is the wave propagates to the left and negative is the wave propagates to the right. K is the represent wave number, and x is the distance of the particle from the origin, means that the distance to the horizontal. So this is the origin. So towards horizontal at any position of the particle is represent as x, horizontal distance. Kalau tadi y, dia adalah vertical distance. Okay. So angular frequency or angular velocity we can denote as omega is equal to 2 pi over t, means that omega is related with the period. So represented by y against t graph. So one complete cycle is the period. And then for wave number is related with k is equal to 2 pi over lambda, whereas lambda is equal to wavelength. It's represented by y against x graph. So one complete graph is equal to wavelength. So as you know that in this chapter 10, we have learned two type of graph, where y against t graph and y against x graph. Okay, next is 10.1c, use particle vibrational velocity and wave propagation velocity. As you know that this is two different type of velocity. First is about particle vibrational velocity. You can use these two equations, where Vy is equal to differentiate y towards t, and then or you can use Vy is equal to omega s squared minus y squared when given the value of y. You can use this one. Okay, is let's say they give you a value of y, but they give you equation, so you can differentiate the equation of y to get the equation of Vy, which is a particle vibrational velocity. So let's say the question asks you about wave propagation velocity is related with the equation of V equal to F lambda. So where V is the wave propagation velocity. Okay, so why the particle vibrational velocity? We need to determine V at a certain position, because as you can see that the particle, let's say the particle B here and particle A. Okay, so let's say they are moving. Okay, so as you can see that the particle moving, the arrow is show you the value of V and the direction of V. Okay, when the particle is going up or downward, so the velocity is 0, because tak ada arrow pun dekat situ. Bila dia reach maximum height, you tengok particle A dengan particle B reach the maximum height, so velocity is 0. Ini adalah vibrational particle. Vibrational particle velocity. Okay, because they are changing direction, changing value. Okay, so when they're going down, okay, at the equilibrium position, you can see that the maximum velocity is reached for the particle A and particle B, but the different direction. So you kena faham lah. Okay, so for vibrational particle velocity, dia changing with time. Okay, so cuma untuk wave propagation, yang wave profile colour kelabu ni, okay, dia moving with constant speed, constant velocity. Okay, kalau speed means that dia punya nilai je lah. Okay, kalau direction dia adalah towards right untuk case ni. Okay, so that's the difference. Nampak tak beza dia? Okay, tapi partikel ni dia moving, dia hanya vibrate pada dia punya position sahaja. Let's say you tengok dekat partikel A ni, even you nampak wave profile is moving, the grey one, tapi partikel A hanya vibrate pada position dia sahaja. I mean dekat position yang sama. Okay, dia tak bergerak. That's the difference. Okay. Okay, based on simulation tadi, kita boleh tahu kalau kita nak cari vibrational particle at certain position, kita just masuk je Y ni nilai berapa. Okay, contoh tadi macam saya cakap, kalau you perasan dekat equilibrium kan, dia punya V adalah maksimum kan. So Vy is equal to omega A squared minus Y. Pada equilibrium Y ni adalah kosong. Jadi you gantikan kosong, you akan dapat balik formula dia adalah Vy is equal to omega surd amplitude power of 2. So omega times dengan A. So lalu you dapat balik V maximum. Macam itulah. Okay, kalau you gantikan Y dengan equal maximum position, so iaitu amplitude, so you akan dapat Vy kosong. So samalah macam video tadi, bila partikel tu dekat maximum point, so dia akan produce V kosong. Particle vibrational velocity is equal to 0. Okay, so look at example 1. So you can see that the figure show the snapshot at the time t0 of a wave travel along the x-axis at the speed of 240 meter per second. So this is the value of V, and then it's travel along the x positive axis, means that the wave is travel to the right lah, towards positive axis adalah to the right. Okay, so determine the wavelength. As you know that the wavelength, because the graph is represent y against x, so one complete 20 cm is wavelength. Okay. Okay, calculate the frequency. Frequency you can calculate by using equation V equal to F lambda, where F is equal to V over lambda. So you can get the value of frequency is 1200 Hz. Okay, write the wave equation in SI unit. So wave equation equal to the general equation y equal to a sine omega t minus kx. Why minus? Because wave propagates to the right. They are said in question, wave travel along the positive x-axis. So I replace here with negative kx. So substitute nilai A is 0.8. cm change to meter because they ask you to write the equation in SI unit. Okay, so then substitute the value of omega is 2 pi f, and then we get 0.8 sine 2400 pi t minus 10 pi x. Okay, next is example 2. A progressive wave is described by the equation y is equal to 0.5 sine 0.25x minus 50t. Okay, where x and y are in meter and t in second, determine the angular frequency. So angular frequency is represent omega. So as you know that the equation general you can compare with the equation given you can compare with general equation. So y equal to a sine kx minus omega t. Tak kisahlah kalau kx dulu ke omega dulu, tak ada masalah. Negatif ni kita just nak tunjuk negative, this is represent the wave propagation sahaja. Okay, so angular frequency is omega. So omega is 50. So 50 radian per second. Next, a wave number. If wave number is k, so k is 0.25 unit is meter per meter, because they are said that y and x in meter. And then the wavelength. Wavelength is come from wave number. So wave number lambda is equal to 2 pi over k. So lambda is equal to 8 pi meter or 25.13 meter. Next is wave propagation speed. Wave propagation speed means that the wave motion. So V is equal to F lambda. So F times with lambda, you get 1.99.98 meter per second. Okay, next is maximum vibrational speed. Vibrational speed is referred to particle. So maximum vibrational speed means that when we use equation Vy equal to omega Z A squared minus Y squared, we need to determine the maximum, means that maximum vibrational speed occur when the particle is equilibrium position. So that's why I substitute Y with 0. Dekat equilibrium position, dia punya vibrational particle speed tu paling maksimum. Okay, so the answer is 25 meter per second. Okay, next example. Okay, the wave equation of the particle is given by y is equal to 10 sine 25 pi t minus 0.05 pi x. Okay, so where x and y in cm and t in second, calculate the vibrational speed of the particle at position x and t equal to 4 second. Kalau dia bagi dalam terms macam x dan t, kita kena differentiate lah. Kita tak boleh guna formula Vy sama dengan omega Z A squared minus Y squared tu, because dia bagi x and t. Okay, so what we have to do is Vy is equal to dy per dt is equal to 10 cos 25 pi t minus 0.05 pi x times with 25 pi. Yang ini saya dah ajar sebelum ni kan, differentiate. So kita differentiate, kita keluarkan dulu 10 and then differentiate sin 25 pi t minus 0.05 pi x, jadikan cos. Differentiate sin dapat function cos and then differentiate again yang ada t is 25 pi. So equation Vy is equal to 250 pi cos 25 pi t minus 0.05 pi x. And then substitute the value of x, 0.5, and t is 4 second. So don't forget to use radian mode. Okay, so we get the value is 782.98. Unit is cm as -1 because I'm using this value in cm. Okay, so unit is cm lah. Okay, next question. A progressive wave is represented by the equation given, and then they ask you to determine the velocity of wave. So velocity of wave is V equal to F lambda. Determine frequency, determine wavelength, and then you can determine the value of velocity of the wave. It's 747.62 cm as -1. Okay, next is maximum velocity of the particle, same as a previous one. So just substitute value of y is equal to 0 because maximum velocity of particle occur at equilibrium position. So Vy is equal to 3.77 times 10 to the power of 5 cm as -1. So unit ni depends on the given. Dia cakap kat sini apa okay, tak boleh main teka lah. Kena tengok. Okay, for this question is bagus because dia bagi equation nampak tak 2 pi dekat luar. So kalau student dia tak perasan, so dia akan mungkin jawab salah lah. So kalau you ada soalan yang you dapat macam ni, you kena tukar dulu 2 pi ni, masukkan kat dalam supaya dia jadi dalam sebutan general equation y equal to a sin omega t minus kx. Tak ada tambahan pun dekat sini. So I dah darab masuk. They will give you equation y equal to 5 sin 20 pi t minus 2 pi x divided by 5. Okay, so the question asks you to determine speed of the wave. So same goes with the previous one. So V equal to F lambda. So substitute the value given. Frequency kena cari, wavelength kena cari, and then substitute, you akan dapat 50 cm as -1. Okay, so next adalah vibrational velocity at time t equal to 0 for the particle at x equal to 5 cm. Jadi macam tadilah, kalau dia bagi t dan x, jadi equation kita tu kita kena differentiate dulu dan baru kita substitute value. And then you substitute lah value, you dapat Vy sama dengan 100 pi cm as -1. Okay. So next adalah use the standing wave equation. So as you know that standing wave equation is come from two combination of two superposition of two progressive wave. They are propagates with different direction. Okay, so kalau you nampak je equation dia tulis dua-dua macam ni, selalunya memang dia ada relate dengan standing wave lah. So resultant wave from y2 plus y1, kita akan dapat y equal to a sin omega t cos kx. So where a here is amplitude of the standing wave, iaitu 2 kali ganda amplitude untuk progressive wave. So kena faham lah, kalau dia tanya, kalau you ada equation untuk progressive wave, let's say A dia ni dekat progressive wave 3 cm, and then bila you kira resultant wave, amplitude ni akan jadi 6 cm, means 2 times of the progressive wave. Okay? So next question, a progressive wave of amplitude 3 cm, frequency 25 Hz and wavelength 24 cm travel in positive x direction. The wave superposed with the similar wave that travel in opposite direction. Write the equation of both wave and obtain the equation of the wave resulted from the superposition. So as you know, that general equation is come from progressive wave y equal to a sin omega t plus minus kx. So substitute value yang ni semua kena carilah, dia dah bagi. So kita tahulah omega cari, wave number pun kena cari. And then kita dapatlah equation of the progressive wave. So satu adalah positif, satu lagi negatif sebab dia nak write the equation of both wave. Okay, so dah dapat yang ni, and then dia suruh cari juga equation of resultant from the superposition. Resultant means y1 plus dengan y2. So kita akan dapat equation 6 means that 3 times 2 is 6 sin omega t. So salin je, sin omega is 50 pi darab dengan t and cos kx, where y and x in cm and t in second. Direct je. Okay. So now we have two wave are represented by the following equation. So you know dah yang ni memang type of standing wave, where x and y in cm and t in second. So the wave undergoes superposition. Choose the equation for the resultant wave that travel to the positive x direction. So positive x direction siapa? Y1 lah, sebab positive x direction means that dia punya ni mesti represent negative. Wave travel to the right lah, negative. Okay, determine the equation of the resultant wave due to the superposition. So means that dia sangat simple. So 6 times 2 is 12 sin omega t cos kx. Okay, maksudnya resultant wave ni adalah merujuk kepada standing wave equation. Name the type of resultant wave. So dia adalah standing wave or stationary wave. Okay, calculate the amplitude of the particle vibrating at x equal to 3.3 cm. So kalau dia minta nilai amplitude ni adalah y. Dia nak nilai ni, tapi dia nak particle vibrating at x equal to 3.3 cm. Maksudnya kita ada value x, tapi kita ada value t, betul? So kita assume that sin 5t ni equal to 1. Sebab bila perkataan amplitude, maksudnya dia adalah perkataan yang paling maksimum lah kan. So equation sin, function sin awak ni kena maksimum. Function ni kalau maksimum dia 1, minimum dia 0. Jadi kita kena assume sin 5t ni equal to 1. Just assume that. Okay, sin 5t assume as maximum as 1. So dia akan tinggal 12 darab 1 cos 2x. Dan masukkan nilai x 3.3. So you dapatlah 11.40 cm. Same goes kalau dia tukar. Calculate the amplitude of the particle at time t is equal to 3 second. Contoh, time t equal to 3 second. So, jadi bendanya sama juga. Bila dibagi nilai t untuk standing wave, jadi x tak bagi. Jadi x ni cos 2x you kena assume sebagai maksimum lah, iaitu 1. Jadi equation akan tinggal 12 sin 5t. Dan gantikan t sama dengan 3 second. Macam tu Alright.